All right. Hey, Brooke. So on this paper right here, the functional group paper on this one, it just wants you to tell if it's an alcohol, a carboxylic acid, aldehyde, ketone, ether, or an ester. So the way we do that is just based off of like what are in those chains. So if it's an alcohol, it's going to have an OH. If it's a carboxylic acid, it's going to have a COOH. Aldehyde will have just a double bonded oxygen, but it has to be on the end, so there's a hydrogen there. The ketone is a lot like that one, only your double bonded oxygen is going to be somewhere in the middle of that chain. So when you name it, you'll have to put a number, like where is that oxygen coming off? An ether is just going to have an oxygen with carbon chains on both sides of it. And then your ester will have two oxygens. It'll have a double bonded oxygen, then it'll have another oxygen here with another carbon group. I'll go into how to name them here in a second, but I was just going to go over those first, so that when you look at this paper here, all they want you to do is to say what kind it is, classify it, and then draw what it would look like. So I did two of them on here, two that I thought were maybe some more of the trickier ones. So this one I know is an alcohol because I see OH, and that is the only one over here that has just an OH with nothing else attached to it. Like this one has an OH, but it's got the other oxygen there. So I know that's an alcohol. And when I go to write this out, I see that it's a CH3. So that's where I put that right there. Then I have a CH, and then the OH is attached to this carbon here. So that's what I've done. I did C, there's the H, and then I attached the OH, the hydroxyl. And then lastly, I've got that CH3, which is what I've done right here. Another example of that would be this one down here. As soon as I see that COO, now if it were COOH, which is what I have on number 1 here, I would look and I would say, okay, that's a carboxylic acid. But since it's COOC, that means that it is going to be the ester right here. So I wrote down ester. And then just to write the thing out, I'm going to do the same thing. CH3, there's my CH3. CH2, there's my CH2. Now this carbon here, it's got a C, and then it's got O, and then it's got another O, and then that is attached to C, and then there's 3 H's. So remember, this is all kind of like a participation like we do in chemistry. So try your best on it. If you mess up, it's not the end of the world. It's just kind of some review for you guys on doing this stuff. Now on this side, where it says circle the functional group, then name the compound below, I just picked number 10. A lot of these seem to be alcohols. There's a little bit of everything in here, but I picked number 10 to do. So what you would do is you would circle that functional group. I wrote it right here. So I would circle that functional group. It's that double bonded oxygen. Now, since it is in the middle, it is a ketone and not an aldehyde. An aldehyde, I'll show you an example of an aldehyde, would be like number 3, since that's on the end. Now to name this thing, on this one I have to put that it is on carbon 2, and I'm going to count the closest way. So 1, 2, instead of going 1, 2, 3. So it is 2, and there are 4 of them, so it's bute. So 2-butanone. Because on ketones, you're going to end it in O-N-E. Now I took a picture of this sheet, and I'm going to send it to you. So you can, I don't know if you have your cheat sheet that I gave you guys, that all of this is on there, but your alcohols are going to end in OL. So butanol, if I were to write this out, bute means 4. And then the OL is telling me that there is an alcohol. Now I didn't put a number on this, so I would assume it's coming off of carbon 1. But if I were to say 2-butanol, then that's going to tell me that OH is coming off carbon 2. Now, I don't know why I tend to count backwards. I could have said 1, 2, and that would have been fine also. On this one, pentanoic acid, that would be 1, 2. Sorry, try to hold the paper and right. 3, 4, 5. And since it's oic acid, we're going to have that OH. Now it's always going to be on the end here. Like I can never do OH here. It wouldn't be a carboxylic acid anymore. So that's always going to be on the end. So pentanoic would be 1, 2, 3, 4, 5. The oic acid means I'm going to have that OOH. An aldehyde, the pentanol with the AL, that would be 1, 2, 3, 4, 5. And since it's an aldehyde, Al, that means that double bonded oxygen will go on the end. And then, of course, there would be an H there. I'm not putting all my H's, but each carbon has 4 lines around it. The ketone, I did down here, 2-butanone. You're just going to end it in O and E, but since that double bonded oxygen can be anywhere in the middle of a carbon chain, we need to tell where it's at. And then an ether. These to me are some of the easiest ones. You are going to have carbon chains on each side. So here's an example, ethyl methyl ether. Once again, it's alphabetical order, so that's why the ethyl goes first. But if this were to be ethyl methyl ether, then that means methyl means 1, ethyl means 2. So I'm going to put a second carbon there. So now I have ethyl methyl ether. So you're naming each side of those. The ester, you always name your oxygen side first. So in this case, it would be methyl. And then I'm going to name this side, which would be methanoate. So down here, the example I gave was ethyl pentanoate. So if I'm naming my oxygen side first, my oxygen side is eth. It's going to have 2 carbons. So I'm going to go ahead and add a carbon there. So this is ethyl. Now pentanoate, that means that I should have 5 carbons here. So there's 1, 2, 3, 4, 5. So that's how I would draw that. All right, so I know that's a lot, and it's been a while since we've done this, and this video is a lot longer than I thought it was going to be. But if you need anything else, let me know, and I'll try to write something or send another video.